Hello everyone. In this video we are going to discuss one of the very important topics of Java, that is called Java collection. So under Java collection we have three major interfaces that we can use. It's called list, set and map. So we have ArrayList, LinkedList and vector that implements list interface. We have HashSet, LinkedHashSet and TreeMap that implements set interface. And we have HashMap, LinkedHashMap and TreeMap that implements map interface. At the end of this video, we are going to discuss comparable and comparator with examples. So let's discuss when to use list, set and map. So these are very popular data structure in Java. So when we'll be using what, it all depends on the business need. So we can use list when insertion order of elements needs to maintained. And we can use set when we need to maintain a collection that contains no duplicates. And we can use map when data is key value pair and need fast retrieval of value based on some key information. So let me show you some hands-on example right now. Then I'll be discussing the difference between list, map and set. Also we'll be discussing all of these subcategories. Now let me show you all some Java collection example. So here I created a class called collection example. So if I open this class, here you can see I declared a variable for ArrayList and I added some items here, and I'm trying to displaying those items here. Then in index number 3 we added item Steve. We are printing that here as well. And inside HashMap the declaration is pretty similar, but this is HashSet, and inside this HashSet we are adding different items. We are trying to add some duplicate items over here, and also we are trying to add null values, multiple null values, and we'll be displaying the result here. And for the HashMap, the implementation is pretty similar, but here we are adding some key value pair. So this is how we can declare HashMap. We are adding the items over here, and here you see we are trying to retrieve some item based on the key values, and this is what we'll be displaying over here. So let me run this program. Let's see what is the output we are getting here. So if we start from ArrayList, here you see this is our initial ArrayList with all the items, and we are trying to add some duplicate items on index 3, and this is how we are getting our list. So it means ArrayList is accepting duplicate values. But if we come here for HashSet, here you can see our initial HashSet, we are trying to add some duplicate values, apple and mango, and trying to add multiple nulls, but in the result set we are getting one null and there is no duplication for apple and mango. So it means HashSet doesn't allow duplicate values, but if you want to add null values, it will be accepting only one null value, right? And then for HashMap, this is how we are adding the items in HashMap, and here we are trying to retrieve item 49. So if we pass 49, we can see Ajit. This is what we are displaying over here. So let's say if we put 2, and if we wanna display the item for index 2, then it will be displaying Rahul, because for this key the value is Rahul. So this is how we can use different type of collections in Java. So let's discuss the difference between ArrayList, vector and linked list. Okay, so at first we'll be comparing ArrayList and vector. So there are few specific items that we can choose for different type of list. So synchronization is one of them. So what does this mean by synchronization? So when we are talking about multi-threading programming, at that time we have to think about synchronization. So like ArrayList is not synchronized, but whereas vector is synchronized. So let's say if we have a situation where we need to think about multi-threading programming, then we can use, like if this is the thing, like yeah, we have to use list interface, then what will be selecting. So as we are talking about or thinking about multi-threading programming, then we have to think about vector, because vector is synchronized but ArrayList is not. Then if we consider the performance, so performance of ArrayList is faster as it is not synchronized, but vector is synchronized. Obviously that may need like more operations to handle behind the scene. That's why the performance of vector is a bit slower than ArrayList. Then data growth, ArrayList increments 50% of the current array size, whereas vector increments 100%. So it, as I mentioned, like it all depends on the business need. Based on the situation, we have to decide like what is the proper data structure to handle the specific scenarios. Let's discuss what's the difference between ArrayList and LinkedList. Again, like if we think about like searching specific items, so let's say we have a huge list that contains like few 100,000 elements, then if we wanna search specific item from that list, then ArrayList is pretty faster over LinkedList, right? But LinkedList maintains a doubly linked list. It has like two different pointers, so that's why it performs slower than ArrayList. Then if we think about insertion and deletion of specific elements, this is the scenario where linked list actually performs better than ArrayList. And if we think about memory overhead, then ArrayList maintains indexes and elements. That's why like the memory overhead here is lower than linked list. But linked list maintains like two pointers, as I mentioned earlier. That's why the memory overhead will be higher over here. Okay. Now let's discuss set. As we already know, set doesn't allow any duplicate values. Okay, we already know that, and we already saw like inside HashSet, if we add multiple null values, then it will be only accepting one null value, right? But there are three different type of HashSet. Set. What are those? So we have HashSet, LinkedHashSet, and TreeSet. So what's the difference between all these three? So if we think about when we should use HashSet and LinkedHashSet and TreeSet, so here are the things. If we don't want to maintain insertion order but want to store unique object, then yeah, HashSet is a good choice. But if we wanna maintain the insertion order, then we can use LinkedHashSet. And if we want to sort the elements according to some of the comparator, then we have to use TreeSet. So what is comparator and what is comparable, we'll be discussing it in next few minutes. Okay. Then regarding the performance, HashSet performance is better compared to LinkedHashSet and TreeSet. Okay, and performance of LinkedHashSet is slower than HashSet because LinkedHashSet maintains linked list internally for sure, and TreeSet performance is better compared to LinkedHashSet, excluding insertion and removal operations, because it has to sort the elements after each insertion and removal of the operations. Okay, then null elements, both HashSet and LinkedHashSet allows only one null objects. I already show you an example of HashSet, so this will be applicable for LinkedHashSet as well. But if we use TreeSet, then it doesn't allow any null objects. Just keep that in mind. So these are the main difference between HashSet, LinkedHashSet, and TreeSet. Now let's discuss what's the difference between HashMap, LinkedHashMap, and TreeMap. So when we'll be using what? So when performance is critical and ordering of the keys doesn't matter, then we'll be using HashMap because HashMap performs better. But if insertion order of the keys should be preserved, then we have to use LinkedHashMap. And when keys need to be ordered using their natural ordering of or by a comparator, then we'll be using TreeMap. So you can read the difference over here, then you'll be easily understand what's the difference between all these three and when we should use what. Now I am not gonna go back to the program and show like how to declare and define map, hash map, linked hash map, TreeMap. So the like it's pretty similar how we declared or how we use like HashMap. We can use like similar approach of a LinkedHashMap and TreeMap. You can search online and you'll be finding like thousands of example over there. But if you understand the basic difference when we need to use what, then that is the key over here. Then you can implement whatever you want to implement using different data structure. So before showing you the example of comparator and comparable, I want to show you one quick example here. So here you see we have a class called a regular sorting demo. Inside this class we have an integer array, and we have another string array, and we created a string list of fruits. We are adding all the items here and we are trying to sort it. So how we can sort it is pretty easy. For sorting an array, we can call this method arrays.sort, and then it will be sorting the array. And how we can sort a list, we can call like collection.sort, and then we can pass this fruit list. It will be sorting the whole list in ascending order. So let me run it. So here you see all of these items is sorted here, and it's pretty easy. We can call this specific method and it will be sorting. But what will happen, let's say we want to sort a list of student or list of author, because those student and author are different type of object and that could have different attributes. So how we can actually sort those kind of list? So to solve that problem, we have comparator and comparable. So let me show you the comparator example first. So here you see under this comparator demo, we actually have an array list of student. And what is actually student? Let's go inside this student class. Inside this student class, here you see we have a constructor that is actually expecting roll number, name, and address. So this is exactly what we are passing here and setting the values. And when we are trying to display the list, so this will be an unsorted list of all these students, right? So now let me run this program to see what we are actually getting as a result here. Okay, so here you see when we run this program, then this is the unsorted list, right? So we are not sorting anything at all. But when we are calling this collection.sort, this is somewhat different than this one, right? So here in the previous example, we passed fruits inside the sort method and it was sorting. But what is happening here? Are we just passing the array or passing the list? No, we are just passing this array list, and at the same time we are calling a class called new sort by role. So if we come here under student class, then you can see we are actually implementing comparator student class. So one is doing sort by role, another one is doing sort by name. So how we can do it? Inside this compare method, we can pass student A, student B, we can compare and we can return the results. So this is what is happening here. So when we are calling this collection.sort, we are passing the array and we are calling specific class, like we want to sort this collection based on what? So we want to sort this collection based on the roll number, and we want to sort this list or collection based on what? Based on the name. So this is how it is sorting. So here you see sorted by role, this is coming first, then second, third. So all of this number is sorted in ascending order. But when we are sorted by name, so here you see whose name starts with A coming first, then B, then C, and based on that the corresponding information will be staying here. So inside comparator, if we want to sort a list of class, then a list of object, then we just need to define based on what property we want to sort. But how we can deal with this kind of scenario? Let's say we want to sort a list based on multiple properties. So there we can use comparable. So let me show you this example. So here you see we have a class called sort author by name, and this is a list of author, and this is how we are actually adding all the items inside this list. So if we go to the author class, here you can see this author class is actually implementing comparable of author. So we have 3 items here: first name, last name, and book name. And here you see we are overriding compare to. So when we will be using comparable, then we need to override compare to method, where we'll be passing this author. So what it is doing, it will be comparing the last name. Then if there is no difference between these two, then it will be comparing first name and it will be sorting the whole list. But what happened with this comparator? So inside the comparator, we are calling compare method, but in case of comparable, we are actually calling compare to method. So let's see what is the output over here. So we know in this compare to, it will be comparing the last name. So the sorting will happen based on the last name. If last name is same, then it will be sorting the result based on first name. Okay, so we can deal with multiple attribute altogether when we'll be using comparable. So let me run this example. So here you see this was the list. So inside author, what it is expecting first. So the first parameter is first name, second one is last name, and the third parameter is the book name, right? So this is first name, this is last name. So what we are trying to do, we want to try to sort based on the last name. So okay, let's see what are the last name here. So it start with M, H, M, H, M, right? So it will be either M or H. So what is coming first? Is it M or H? So H come first, right? So this is H. So how many H do we have? So we have Hopkinson. So we have this and this. When the last name is same, then we'll be comparing based on the first name. So out of these two result set, which one should come first? So Deborah should come first, right? So that's why it is coming first, and then we are getting this result. Hello, right? Then okay, then what will be the third one? So we know we already identified this and this. Then see, we have Miller and Martin. Then which one should come first? I think Martin should come first, then Miller. So that's why in the third row we are displaying this result. Then what should be the fourth and fifth one? So fourth and fifth last name is same. Then we will be comparing with the first name. What is the first name? So which one should come first? So Frank should come first, then Henry, and this is exactly what we are getting over here. So this is how we can actually use comparable. So let me summarize our discussion here. So what we discussed so far in this lesson we discussed different type of interface like list, set, map, and all different types like ArrayList, linked list, vector, and also we discussed the difference between HashSet, LinkedHashSet, TreeMap, and also discuss HashMap, LinkedHashMap, and TreeMap difference. And also we discuss comparable and comparator interfaces, when we should use what and how we can use it. I hope that was helpful for all of you. Thank you so much.